This is Ryan Flowers here, Whiskey 7 Romeo Lima Foxtrot, and I'm here to show you today the BITX40 and its VFO slash BFO, which is not the Arduino. So you might recall that the BITX40 originally came out in 2016, I think it was, with a built-in VFO that was not digital and just drifted like it was on Fast and the Furious. So that had to go, and I originally used a QRP Labs VFO kit, which I really loved, but I thought it'd be so much fun to roll my own, and that's what I did. So I really wanted to use a rotary encoder, so there's a rotary encoder with the 37mm knob, which you can get on Amazon. There is, underneath here, an Arduino. You know what those look like. And this is the VFO or a QRP Labs Arduino Shield, which accepts the QRP Labs synth kit, which is the VFO and BFO used here. It can be used for all sorts of things. The display is your standard 16:2 LCD, but it's got that I2C kit on it. So I think that cost me about $5. Again, got that on Amazon. I'll link to it below. Actually, on my blog. Go to my blog and you'll get the link for it. Anyway, use one of those because I wanted to cut back on the amount of wiring involved. That is powered by this guy. That's just a 7805 voltage regulator circuit with a built-in power switch that goes way over here. And then you see my other BITX40 bits and pieces. Now you'll notice there are two cables going to the main board. There's the one on the left, which is the BFO, and the one on the right, which is the VFO. And the VFO here, you'll notice that RG174 is only shielded on one side. If you look down here, the shield and the center conductor are both soldered in. But if you look carefully here, only the center conductor is soldered there. And the reason for that is to prevent ground loops. So you still get the benefit of shielding without the ground loop. Same thing is done on the BFO. And this pin did not exist before I soldered it in. It's just next to that capacitor there. And that capacitor normally is putting out a 12 megahertz signal from this. This is just an oscillator here, an oscillator circuit based on this 12 megahertz crystal. But this whole circuit is off because it's actually not powered because I moved that resistor over. So it's actually not getting any power. So all the RF, all the frequency is coming in. Just basically, this is soldered next to that capacitor because it was convenient. And then that goes through this mixer right here. Or not mixer, but rather transformer, which I believe is T6 or something like that. But anyway, that covers the beat frequency oscillator and the variable frequency oscillator. So by adjusting this frequency over here on oscillator 2, which is the output, actually clock is 1, and this is clock 0 on the SI5351. So clock 1, clock 0. I'm sorry, clock 0 and clock 1. And by varying the BFO frequency, we can get lower sideband and upper sideband without having to do any fancy tricks. And then this comes from the power supply and powers it up. There's that. And that's not exactly on. Here we go. And that's it. So I'll link to all this stuff below, and I want to thank you for watching. Make sure you click subscribe and do all the things that get you all the notifications. If you would, and I'm being serious, go subscribe at miss.geek.com. I'll save you some trouble. You don't need to subscribe here on YouTube. You could actually subscribe at miss.geek.com. And if you go to the top right corner, there's a subscribe little form there. You put in your email address, and I'll send you an email every time there's a new blog post. And if there's a video involved, you'll get that too. So that way you can cut down the amount of notification spam you get. So anyway, thanks for watching. I hope that this was informative to you. And oh, you're probably wondering, Ryan, what about the software? I'm actually not focusing on the software because the software on this is not very good. It's a modified micro-BITX sketch. And the micro-BITX sketch is hacked and just beat to death. And the only reason I'm using it is because I really wanted to use a rotary encoder, not a potentiometer for tuning. And I don't know Arduino well enough to actually code it myself, so I used a sketch that I knew. And then I hacked on it forever and got it working. And it's ugly and it barely works, so I'm not sharing the code because I don't think I'd be doing anybody any favors. So if you know of some code that would work, please let me know in the comments below. 73, have a great night, and thanks for watching.